In this slide, we are going to cover the electric field strength. Electric field strength. But before moving towards electric field strength, I will like to cover another topic, that is sign convention. Sign convention for electric and gravitational force. One sign convention was for vectors that you studied in your A1. It was, if you take the direction towards right as positive, then direction towards left will be negative. You studied this. Now in A2, we have two sign conventions, interestingly. One sign convention is same as you used in A1, and we have a new sign convention as well. When to use that sign convention, what are its applications, and obviously, why not the sign convention that you studied in A1, which was for vectors? So first of all, to calculate newtons, or more precisely net force. If you are calculating newtons or net force, the sign convention will be different. And if you are calculating the electric work, to calculate joules, these joules could be gravitational joules, electric joules, joules in a field. Joules in a field. The sign convention will be different. So we have two sign conventions. One is for the calculation of newtons, and the other is for the calculation of joules. If you are calculating Newton, to calculate net force or newtons, take the force as a vector, take the forces as vectors, and write the sign conventions for directions. Vectors, and use same convention as you used in A1, that was, if right is positive, then left is negative. If the direction towards right is positive, then the direction towards left is negative. Or more generally, if one direction is positive, then the opposite direction is negative. Now, what about the calculation of joules in a field, work in a field? To calculate the work in a field, we take this convention. For example, you may have attraction or you may have repulsion. The positive charges will, they will repel each other. The positive charges will repel each other. Now, the displacement vector that we take, or the displacement that we take, is outwards. Generally, displacement of things in A2 is taken outwards. Now, for example, if we let these charges go in their way, they are already repelling each other. Because of repulsion, you see they will move outwards. So their displacement or motion will be outwards on their own. So we generally take the displacement vector outwards. So this is their displacement vector. When they will move outwards, for example, this is Q1 and this is Q2. You see, work on Q1, for Q1, the motion and displacement, they are in same direction. So for Q1, the work will be positive. What about Q2? For Q2, even for Q2, the work is positive. So because of this positive work, we assume the repulsion to be positive. So when you are calculating joules in a field, repulsion should be given. Repulsion is given a positive sign irrespective of individual directions. Because if you follow the individual directions, then force towards left will be negative, force towards right will be positive. No, when you are calculating joules, forget about the individual directions. You'll apply a sign for repulsion. Repulsion is given a positive sign irrespective of individual directions. So the summary of all this is to calculate net force or newtons. When your question is about calculation of newtons, then a repulsive force will not be considered, but the individual forces will be considered. Since net force is calculated on a single object, so this force and this force, the one that is towards left will be taken as negative, the one that is towards right is taken as positive. So while calculating net newtons, and net newtons cannot be calculated on two objects, they are calculated on a single object. For example, if this has a force of plus 5 Newton and another force of, for example, in this direction, 9 Newton, this is left side, so it will be taken as negative. So F net, if you want to calculate F net on this charge, it would be plus 5 Newton minus 9 Newton minus F. So when you are calculating F net, you take the forces to be, you take the directions. Even if you calculate F net on Q2, for example, this was Q1 and this is Q2, to calculate F net on Q2, it would be positive F. So when you calculate net newtons, go with right and left. The direction towards right in A2 will be given a positive sign, and the direction towards left will be given a negative sign. When you want to calculate electric work, to calculate the electric work or joules. So when you want to calculate the electric work or electric joules, or even for gravitational work, the repulsion as a whole, the repulsive forces F and F, since we take the displacement outwards in any case, so the force which is in the direction of displacement vector will be given a positive sign. If you let them move outwards, then both of them will experience a positive work. That's why repulsion is given a positive sign irrespective of right and left or individual directions while calculating the electric work. So repulsion in any direction, repulsion in any direction will be given a positive sign while calculating electric work. While calculating electric work, the repulsion will be given a positive sign. And what about attraction? For attraction, for example, you have two masses, they will attract each other. The masses always have attraction. Now it depends what you are calculating. You are calculating net force or you are calculating the work. So this is, for example, a gravitational fields force. It's a gravitational field in which you have gravitational force. To calculate gravitational net force, to calculate gravitational net force, the direction towards right is taken as positive and the direction towards left will be taken as negative because you are calculating net force or newtons. Now, what about if you are calculating joules? To calculate work in a field. Work in a field could be electric work or it could be gravitational work. In any case, for example, you have two masses, they will attract each other, and this force will perform the gravitational work. Generally, we take the displacement vector or the motion outwards. This is by convention. So, displacement vector is always taken outwards while calculating electric work because work is the product of force and displacement. Now, when the displacement vector is outwards, both the forces, irrespective of their direction, will be negative. So, even if you have a positive charge and a negative charge, you see they will attract each other. And if you are calculating the electric work, then both of them, since the displacement vector is outwards, we take the displacement outwards. This is the convention. So both the forces will given a negative sign, will be given a negative sign because the forces are opposite to the displacement vector or the motion that we take. So while calculating electric work or joules in a gravitational or electric field, in general in a field. So while calculating electric work or joules in a field, the attraction is given. The attraction is taken to be negative irrespective of the. So while calculating electric work or joules in a field, the attraction is taken to be negative irrespective of the individual directions. So signs in a field are given with respect to what you're calculating. If you're calculating net force on an object, so you should apply the signs. And the signs will follow the vector convention when you calculate the net force. So if you are calculating the net force or newtons, then you have to apply signs according to A1 convention, that is, direction towards right should be given a positive sign and the direction towards left should be given a negative sign. However, Instead of that, if you're calculating work or joules in a field, then you have to take the attraction to be a negative force and a repulsion to be a positive force. So while calculating the joules, you have to give repulsion a positive sign. For example, if this is a positive charge Q1 and this is a negative charge Q2, now they will attract each other. And by convention, the attraction while calculating electric work, the attraction is given a negative sign. So while calculating electric work, the attraction will be given a negative sign. The reason for that, we already discussed that. Because we take the motion or the displacement vector in any case outwards, although we know that if these two charges are left alone, they will move closer. However, some external factor, it could be a human being or something, will take them away. So, the work done by the forces which are taking them away is not counted. The work done by the electric force is counted. On the both on both the objects, the displacement is outwards, the force is attractive, so the work will be negative. That's why the attractive force is given a negative sign. So work for this one will be negative and work for this one with outwards displacement will be negative. So the work will be negative and hence the force is also given a negative sign. So attraction is given a negative sign and repulsion is given a positive sign. And this is convention for attraction and repulsion. Convention is used for the calculation of work. While calculating the net force, you count the individual directions. Okay, students, in the next slide, we'll cover the concept of electric field strength, electric potential, and all of that. Take care, students.